250 million years ago, 95% of the species living on Earth vanished. It's one of the greatest murder mysteries of all time. We know that flood basalts in Siberia release sulfur dioxide into the atmosphere, creating deadly acid rain. Temperatures dropped suddenly, causing a savage freeze. Plants and animals perished. But that was just the beginning. Next, the Siberian traps released an even more deadly killer. A killer that triggered a heat wave. The molten rock released huge amounts of another gas into the atmosphere, carbon dioxide. As much as 6 times more carbon dioxide was pumped into the atmosphere as we have today, according to paleontologist Peter Ward.
Carbon dioxide goes up in the atmosphere, doesn't go into space, blankets the planet, and it acts very much like a greenhouse, and that's why we call this a greenhouse gas. It effectively traps heat. Sunshine comes through the blanket one way, but can't get back out again. It's trapped inside. The blanket of heat warmed the entire planet. There's no place to hide, no place to go.
As the Siberian traps continue to erupt, carbon dioxide builds up and up. The heat wave begins. In the Karoo Basin, temperatures suddenly leap 15 degrees. The result, catastrophe.
If it had happened over 1 million years or so, animals and plants would have adapted. But the reason it was so disastrous is that it could happen over a very short space of time, perhaps 10,000 years at some estimates.
The rock layers reveal the exact time when the sudden heat increase turned this lush plain into a desert.
The bluish-grey mud rocks of the Permian represent wet floodplains, a time when the water tables were very high, there's lush vegetation.
As the Earth heats up, more of the planet's water evaporates. Rivers dry out. Iron-bearing rocks, normally underwater, turn rust red as they react with oxygen in the air.
In short, it's the first time we see drought in the Karoo Basin.
Vegetation withers and dies. Plant-eating animals begin to starve and die out. As the plant eaters vanish, predators like Gorgonopsian lose their prey. They too start to die. The wipeout has begun. The land is dying, but life is not safe even in the oceans. Marine life too is under pressure. Geologist Paul Wignall discovered vital clues about the marine wipeout when he traveled to Greenland in the 1990s. He found an extraordinary record of mass extinction.
Whoa.
Wignall discovered that the Permian marine extinction wasn't a single event. It happened in stages. In early rocks, he found plenty of fossils. Clearly, there were many species alive at this point. Then, over tens of thousands of years, the number of species dropped off, until suddenly, almost none remained.
We really lose virtually everything that was in the oceans at the time. We've wiped out about 95% of the species, and the oceans are pretty empty now.
What killed them? The rocks here tell a story. The creatures may have suffocated from lack of oxygen.
What we found in the sediments is lots of crystals of a mineral like this is pyrite, which is also known as fool's gold. It cannot form in the presence of oxygen. It just hates oxygen.
If pyrite crystals could form in the sea, then there wasn't much oxygen. Normally, oxygen dissolves into seawater at the surface. Currents that circulate between the equator and the poles then carry the oxygen with them. Because there is more sunlight at the equator, the sea here is warmer. As this warm water moves toward the poles, it cools and sinks, carrying that dissolved oxygen down into deep water. The oxygen-rich water then runs back toward the equator along the ocean floor, and the cycle continues. 250 million years ago, in the aftermath of the massive volcanic explosions in Siberia, that mechanism fails. The same heat that has dried out the floodplains now warms the oceans, even at the poles.
I'm sure the oceans around the equator may have reached temperatures approaching 100 degrees Fahrenheit, real warm sort of bathwater temperatures near the poles and so on. You're looking at temperatures more akin to California today.
With no cold water at the poles, the ocean's circulation system shuts down. Oxygen no longer mixes down into the water. Sea creatures start to die off. First the land, then the seas. The Siberian flood basalts affect everything. They leave the oceans almost entirely dead. But scientists aren't convinced that heat alone could wipe out as much as 95% of life on land. For that, they need another explanation, another smoking gun. They now believe that at the end of the Permian era, conditions are just right for one last killer, the most deadly of them all. It's a killer that's still with us today. All you need is a swamp.
Ooh, that smell is a horrible rotten egg smell. It comes from the bacteria in the sediment. They produce hydrogen sulfide gas, which is a very toxic gas. They do so only in conditions of low or no oxygen, such as a swamp.
In the low oxygen conditions of the Permian period, these bacteria do more than just smell. In larger quantities, the gases they produce kill.
If the Earth had low oxygen everywhere, and the small amount of hydrogen sulfide would be multiplied immensely to the point that it would be dangerous for life on the planet.
We know sulfur-producing bacteria flourished during the Permian extinction. Their fossils are there in the rocks in quantity. Their presence suggests that by the end of the Permian period, the air itself was deadly.
And you have a new type of kill mechanism. And this is the evidence that, to me, has, I think, solved the whole mystery.
The sulfur gases may have delivered the final blow, even to the hardy Gorgonopsians.
So if our poor Gorgonopsian is in a case with low water, low oxygen, plus it's harder to find food. And now hydrogen sulfide is coming out. Well, you've got a weakened animal, much more susceptible to dying off. And then finally comes a year where one poor last female is looking for the male that isn't there, or vice versa. And then they're extinct.
Wipeout. It's happened once. Could it happen again? This time to us? Flood basalts strike on average every 20 million years. Really big ones, like the Siberian traps, are rarer still. But they do happen. At some point in the future, it will happen again.
There's nothing we could do about it. We'd have to stand back and be awed and amazed, and it would be rather depressing as well.
If the worst does happen, humanity may not survive.
That the Siberian flood basalts constituted the greatest mass extinction ever seen on our planet, and if something like this happens again, we may well be one of those species that will disappear.
In terms of sustaining a complex civilization, that would be the last thing on people's minds. The simple fact of existing would be trouble.
Just how would we survive as a species? Very few Permian creatures survived beyond the extinction line, and those that did were the most adaptable. One, the Lystrosaurus, evolved a long, sturdy snout, handy for chopping through the few hardy drought-resistant plants that were still around. Other species made it through by living underground. Could we survive the same way? Most scientists are unsure.
Surviving on the ground for hundreds of thousands or millions of years is just not going to happen. We don't have any technology that would be able to cope with this sort of thing at all.
So when it comes to the crunch, it's going to be those humans that are better adapted to living underground, low oxygen conditions. They will be the ones that will survive. It'll be survival of the fittest again.
Even the best may not be good enough. The planet above those few hardy cave dwellers would be wrecked. Hardly any vegetation. Almost no life at all. If the Earth is hit again by a Siberian-scale flood basalt, our chances of survival are slim. Wipeout, strike two. Not all mass extinctions are caused by asteroids or volcanic lava. Some may be triggered by a sudden blinding flash of light from exploding stars. A burst so powerful that it may have caused the second largest wipeout in Earth's history, and could happen again. We're the top species on Earth, but that's no guarantee of survival. Look back 440 million years. The dominant species is the trilobite, a crab-like creature that has already ruled the seas for 100 million years. Now they are dying out, along with 70% of all the species alive. It's the second largest wipeout in Earth's history, the late Ordovician. Unlocking the secrets of their demise is paleontologist Bruce Lieberman.
If an alien from outer space was visiting, they would probably characterize life on Earth as dominated by trilobites. Most of them were probably scavengers. There may have been a few forms that were predatory on things like worms.
Scientists originally thought that a global ice age had caused the wipeout. There was evidence of ancient ice deposits in the Sahara Desert. But Lieberman isn't convinced it could have killed so many species.
We have had other glaciations in the geological past that do not produce mass extinctions on the scale that we see at the end of the Ordovician. So that's why we can't treat it as a smoking gun.
By chance, Lieberman was invited to a discussion held by astrobiologist Adrian Malott, who had an idea he wanted to explore. Malott studies gamma-ray bursts, the most powerful explosions in the universe. NASA's SWIFT satellite, launched in 2004, detects on average a gamma-ray burst a day. Scientists don't know what causes all gamma-ray bursts, but they do know that the worst and most deadly for Earth come from giant exploding stars called supernovas.
A small fraction of those would be on our side of the galaxy and would have the beams pointed at us. If that happens, we have a recipe for disaster. The effects are so severe that you naturally think of mass extinctions.
Malott was sure that one must have hit the Earth in the past, but he didn't know when. He asked Lieberman if there was a mass extinction that might fit with his ideas.
When Adrian Malott described what would happen if a gamma-ray burst was sufficiently near our planet, I literally had an aha moment.
Professor Lieberman said that sounds like the Ordovician extinction, and we thought we had a connection.
The two scientists needed to reconstruct what would have happened if a gamma-ray burst had hit in the time of the trilobites. Space, 440 million years ago. A supernova explodes. It's within 10,000 light years from Earth, but that's close enough to be deadly. A massive burst of gamma rays heads toward our planet. First to suffer is the atmosphere. The gamma rays change the chemistry of the air itself. The huge blast of energy rips apart nitrogen and oxygen molecules, enveloping the Earth in smog, including the deadly gas nitrogen dioxide.
The very dangerous genie in this bottle is nitrogen dioxide, normally present in the atmosphere in very small amounts. If I were to open this bottle, we'd all be choking and gasping. In the aftermath of a gamma-ray burst, the whole atmosphere of the Earth would contain large amounts of this.
This smog blocks out sunlight and sends temperatures plummeting, possibly even triggering an ice age. But there's another more devastating effect. The initial gamma-ray burst and the growing cloud of nitrous oxides destroy the ozone layer, the very thing that shields Earth from the sun's lethal ultraviolet radiation.
Many plants and animals would die. It might even be sufficiently severe to cause a mass extinction.
The sun itself becomes an agent of death. 5 times the normal amount of UV radiation hits the Earth. It damages the DNA of almost every plant or animal it hits. The smog acts like a sieve. It allows UV light, which has a short wavelength, through, just like a sieve allows flour through. But it blocks the longer wavelength light that provides us with heat. In this demonstration, the sugar, which unlike the flour, doesn't get through the sieve. Without the heat from the sun, temperatures sink to a deadly low. A single gamma-ray burst, just a few seconds long, could trigger an ice age and damage the DNA of almost every living thing. It was the breakthrough Lieberman had been looking for.
That, in effect, is the 1-2 punch that may have caused this mass extinction.
UV radiation can only penetrate a certain distance through water. The deeper an animal lived in the ocean, the more likely it would survive. And that's what Lieberman found. The young of some trilobite species stuck close to their families on the ocean bed.
These guys are the lucky ones. They didn't know that this mass extinction was coming, but they were shielded from the ultraviolet radiation.
Babies of other species swam close to the surface,
which makes them far more susceptible to the effects of a gamma ray burst. In particular, the increase in the ultraviolet radiation would mean that the baby or juvenile form would be far more likely to be zapped.
Lieberman had finally found a likely suspect for the trilobite extinction.
To find something that could potentially be responsible was extremely exciting.
The mystery of what could have killed 70% of all life in the oceans was solved. Wipeout. So what are the chances that we'll follow the trilobites into oblivion? We think there isn't a star close enough to cause damage at the moment. But if a burst hit, we'd be in trouble. Gamma rays travel at the speed of light, the fastest thing in the universe. There would be no warning. The first we'd know would be a blinding flash of light.
If you were looking at the sky, you might well be blinded by such an event.
The pulse would be over in seconds. Within hours, a cloud of smog would engulf the planet. The immediate danger would be sunburn and skin cancers. Then the DNA damage would begin. Adrian Malott has calculated that it could take years before it was safe to go back outside.
Even after 4 years, the level of DNA damage is still higher than it was before the burst went off. And it'll take 10 years to get essentially back to normal.
Humans might survive by staying indoors, but plants and wildlife would be devastated.
Billions of people would have starved to death because many plants and animals would die.
I think the human species would survive, but the amount of population that could be supported would be perhaps 5 to 10% of the population on the planet today.
So it would be a full-scale worldwide disaster.
A gamma ray burst also delivers an electromagnetic pulse. It would fry anything that relies on electronics. Our entire infrastructure would collapse.
Many of us would be living in the 19th century again.
This disaster wouldn't last as long as a flood basalt. It wouldn't be Armageddon like an asteroid impact. A gamma ray burst would affect us maybe for a decade. Billions would die. But this is one wipeout we might just survive. Gamma ray bursts are incredibly rare. Mass extinctions are rarer still. Chances are we're safe, right? Wrong. Scientists say we are in the middle of a mass extinction right now. Could our own date with destiny be just around the corner? Tense lethal radiation then rains down on our galaxy and eventually Earth. Normally, our galaxy and our planet are protected from cosmic rays by the galaxy's magnetic field. But our solar system moves up and down within the galaxy. When we're deep inside, we're protected. When we move up from the thick central disk, we're exposed. Imagine a diver deep in the ocean. It's pitch black. No light gets through. As she rises to the surface, she's exposed to more and more light.
And when the solar system and the planets go close to the surface of a galaxy, it's like being close to the surface of an ocean. They are more exposed.
Medvedev has calculated that this increased exposure happens between every 62 to 64 million years. That's when extinctions happen. Only one event doesn't quite fit the pattern: the asteroid strike that wiped out the dinosaurs. If the galaxy theory's right, does that mean the flood basalt and gamma ray burst theories are wrong? Not according to Malott. He says the cosmic rays periodically weaken life on Earth. When the other catastrophes hit, organisms are less able to survive.
It's like being shot when you have the flu. You're much less likely to survive.
According to the theory, Earth will get cosmic flu again in 10 million years. But will humans be around to experience it? Or will we have destroyed our world before then? In the Permian extinction, volcanic eruptions started a chain reaction. Carbon dioxide swamped the atmosphere. Temperatures rose by 15 degrees. It killed 95% of all the species on Earth. Sound familiar? It should. In the last century, we have more than doubled the amount of carbon dioxide in the atmosphere, and it's still rising. The next wipeout could be entirely our fault.
It is a warning from history, the fact that the sort of rate of increase and the levels that are being attained has happened before, and it was bad before, and if we're not careful, it'll be bad again.
Well, I'm very worried that we are heading down a very nasty path. If there is a chance that we could head to another big mass extinction because of what we're doing to the climate, then we have to do everything in our power to stop it.
At present, no one knows if man-made climate change will cause a global wipeout. But we certainly have the power to make life on Earth as tough as it was during the Permian extinction. Our world could become uninhabitable, our survival a question of luck. Beyond even that threat lies another. If we survive asteroid hits, gamma ray bursts, and the effects of our own success. In the long run, the sun will make life on Earth impossible. It will expand and melt the surface of our planet. Humans will only survive if we change our address. After that, billions of years from now, the universe could rip apart, and that would be the end of everything. No life, nothing. One day it will all be over. The question is, how long have we got?